Yo, yo, man, what's up, everyone? It's your boy, Jay. Oh, eh, 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 eh. We're back to Monday. We're back. We're back with that hammer. Be back. How you doing? How you doing, YouTube? How you doing, Twitch? How you doing, fellow energy consumers? Fellow ATP consumers would be human beings, right? With some more broad term. Energy, calories, joules, electron energy is basically movement of electrons, right? So if you think about it, fellow entities that consume the movement of electrons. Yeah, I see you. I see you. Okay, thermodynamics assignment. What do we got? What do we got? It's not gonna lie, it's getting hot. It's getting hot. Is it me or is it just the room is too hot? You know, I'm just saying. Is it just me or? I know it's not the summer. Maybe it's just me. Okay, thermodynamics exercise 3. There we go. Organic, you might have to sit this one out. Define the 4 basic laws of thermodynamics. Fuck. I remember this question on last year's fucking thermodynamics exam. I failed it, but what? I thought you always win. Nah, sometimes people fail. Fuck, I need to get that bag. I need to go get the bag. Gotta change the fucking description because Restream just keeps on plugging itself. There should be a way to get rid of that. If I could set up a small AI agent that kinda just removes it. I hate the sound of swallowing. So weird. God knows. What is my or yeah? When was this? 25th of May. That's today. Focus. 15 minutes. ChatGPT is so fucking slow. Define the four basic laws of thermodynamics. Bulk movement of fluids versus the first law. When you blow a puff of air, it moves outwards with some kinetic energy. However, this movement doesn't continue forever. When you blow a puff of air, it moves outwards with kinetic energy. However, this movement doesn't continue forever. What happens to the kinetic energy of the air as it slows down? How does this process relate to the first law of thermodynamics, which states that energy cannot be created or destroyed? So when you blow air, the kinetic energy in the air converts to potential energy by interacting with other stationary air molecules. Huh? And fuck, energy cannot be destroyed or created. So my lungs is what created the energy to blow the air, but where did my lungs get the energy to do that? From the food. Where did food get the energy to give me energy? Whoa, wait. Sun! Sun. But where did sun get the energy? Where did sun get its energy? It just cannot get from immense amount of mass, hydrogen atoms, hydrogen, helium, fissure, nuclear fusion. I'm not exactly sure. Wait, where does sun get its energy? Because energy cannot be created or destroyed. How does it come in full circle? I have information from the part where energy is spread across other stationary air molecules when I blow it out from my mouth. And I got the part where my lungs get the energy, and the food that provides my lungs the energy, the the sun that provides the plant to make that food, to store that energy. But the sun, where does sun get its energy? Immense mass, where? Uh-huh. Mm-hmm. I know I can ask AI, but let me run this model in my head. Let me see if this thing is good enough. Sun is losing energy, it is but energy cannot be lost. It's always absorbed type shit, but how is how is this relating to the sun losing energy? How is me breathing out relate to the sun losing energy? Compared to the amount of energy the sun is losing, mine is measurably small, but still it's energy. And there's the other part, right? The entropy, the total entropy of the universe just keeps on increasing. Uh-huh. Okay, on that perspective, I kinda understand what sun losing its energy, because only if sun lose its energy, the entropy of the universe increase, right? But then that contradicts energy cannot be created or destroyed. Only if entropy is not energy. Entropy still consists of energy, right? Am I stupid? I am. I am stupid. What else? Maxwell's demon. It's just one question. Oh, fuck. 14, 15, 16, 17. Okay, okay. I did not know there is a lot of questions. Maxwell's demon. In a famous thought experiment, physicist James Clerk Maxwell imagined a demon controlling a door between two chambers of gas. The demon allows only slow moving molecules to pass into one chamber and fast moving molecules into other. Over time, the chamber becomes colder. One chamber becomes colder, the other one hotter, seemingly without any work being done. Which law of thermodynamics does this scenario appear to violate, and why? Ignore any effects related to the information processing by the demons. Okay, like it's a good question. So demon allows only slow-moving molecules to pass into one chamber. The chamber becomes colder. Okay. Mm-hmm. Enthalpy and entropy. Calculate the total change in enthalpy and entropy of 360 grams of chloroform when it's heated to its boiling point from 25 degrees Celsius and completely vaporized. Use the following values for your calculation. So this is the final temperature, right? Which contributes more to the total increase? The temperature rise or the process of evaporation? The temperature rise or the process of evaporation? I'm guessing the process, the temperature, right? That's more fundamental. Gibbs free energy. Consider the water gas shift. Calculate the change in enthalpy and entropy for the given reaction. Use the values in the table given below. At what temperature does the given reaction flip between spontaneous and non-spontaneous? Assume delta H and delta S to be independent of temperature. Is this reaction spontaneous above or below the temperature calculated in number B? Phase diagram. Consider the two phase diagrams given below to answer the following questions. Oh, I hate this one. Not hate. I interacted with this question more than one time. Clausius-Clapeyron. Derive the integrated form of Clausius-Clapeyron equation from the Gibbs free energy. Okay, that's kind of a long one. Pay special attention to simplifications or assumptions made during the derivation. Which phase transition does the CCE apply? And why? Okay, the Clausius-Clapeyron. Clapeyron. 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 Why? Hiker is making tea at Mount Everest. They notice that the water boils at 68 degrees Celsius. Calculate the atmospheric pressure on the top. I did the same question, but it was not the hiker. It was something else. State Troton's rule. Does it apply to example C? Oh, fuck was Troton's rule? I forgot. Cryoscopy. Oh no, there is not the end. There's one more. Cryoscopy is a method used to determine the molar mass of the dissolved substance by measuring the freezing point depression of the solvent. Molar mass of a dissolved substance by measuring the freezing point depression of a solvent. When a solute is added, the freezing point of the solvent decreases. The behavior can be described with the following equation, where delta T is the difference in melting point, Kf is the cryoscopic constant, and B is the molarity of the solution. Give 3 examples of colligative properties. You measure the freezing point 25 grams of cyclohexene. Pure cyclohexene freezes at 6.5 degrees after you add 500 milligrams of the unknown solute to the high flow. To the cyclohexene, you observe a freezing point of 5.3 degrees Celsius. Use the cryoscopy constant of cyclohexene to calculate the molar mass of the sample substance. I know that I'm gonna do a presentation on this one. I need to decide which question. Not gonna lie, the first one seems cool. The first one seems cool. Laws of thermodynamics, but this one is too broad. This first question is too broad that I don't know. It doesn't. It's not like it's gonna make a lot of sense the more you answer. Melting and boiling of binary mixtures. Binary mixtures behave quite differently from pure substance when undergoing phase changes. In addition to pressure and temperature, the phase behavior also depends on the composition. To avoid three-dimensional phase diagram, which can be difficult to work with, this means phase diagrams of binary mixtures usually keep one of these parameters constant while showing the interdependence of the other. Independence? Did I just say independence? I was about to say independence. First sign of distraction. In ideal system, phase change lines for melting slash flash fusion for melting and bubble point dew point line for vaporization can be described as the weighted average of the components. Many material combinations heavily deviate from this ideal behavior. These deviations are called eutectics in case of melting and azeotropes in case of vaporization. What is the eutectic point? That's not gonna lie, I came across these two stuff on my 5th semester class for, oh fuck, I forgot what's the name. Biochemical thermodynamics, some shit. Okay. Based on the boiling point diagram of ethanol and cyclohexane given below, estimate the azeotropic point of that binary system. 15 minutes already? Already, gang? Yep. Push-up time. It's been a while since I took some push-ups. Oh no. Email. I'm scared of emails now. For the protocols can be now longer and the status been updated. For those who have status correction not accepted, I will send it out the deadline for the new submission by tomorrow by the latest as apply for the students of Moro. Please accept. Please accept. I don't want to do this. Accepted. Okay, thank God. Thank God. Correction. What? Section 3 correction not handed in? What? Just a minute. I don't get the section 3 not handed in. Did I put it in the wrong folder or something? No. God damn. God damn. Again, I got distracted, but I'll be distracted for 2 more minutes. Nope. Oh la la. Oh la la. Whoa, what? You just give me a suggested post? Really? This? Mm-hmm. Oh, this guy is fucking weird, bro. What the fuck? Okay. 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 I distracted for a while, but we're back. We're back. Push-ups. Damn. I'm fucking rusted. 'Need more air. $19. Damn. I think my breathing levels are back to normal. Fuck. Should I open the window? Cause it's just getting hot. It's just getting hot in here. She's getting hot. Oh no, sunlight. My boy. It's still hot. I'm guessing. I'm guessing it's not the summer. It's just something else. Crack it open. Crack my boy open. Please, the keyboards be working, please. Nope. I need to reconnect the keyboards. kidding me? You kidding me, fam? Where's the keyboard? Bluetooth keyboard. We connected, boy. Let's go. Can I add a new one? There's one more with the food. No, not the task, bro. It's the food. I wrote the recipe for the food. You stupid fam. Nope. Yeah, Bretteljaus, where is that? Where's the Bretteljaus, gang? Should be here. Why is it not here? Okay, you know what? I'm gonna add it to. Okay, it's still syncing. Okay. I don't right now. I don't care. New one, right? New file. What is my usual heading? Thermodynamics exercise sheet 2, 3. Okay. No internet on my phone, okay. Four laws of thermodynamics, 0 to law. If two systems are each in equilibrium with the third system, they are also in thermal equilibrium with each other, defines temperature. First law of thermodynamics, energy cannot be created nor destroyed. Second law of thermodynamics, the entropy of an isolated system tends to increase over time. Entropy of an isolated system, yeah. What the fuck is this? I'm still confused on that thing. As temperature approaches absolute zero, the entropy of a perfect crystal approaches zero. Bulk movement of fluids versus the first law. When you blow air outwards, the air initially has kinetic energy. I mean, the isolated system. So when we say isolated system, it's basically A system with the boundaries does not absorb energy. The boundaries does not let energy pass. It just contains the energy, right? Yeah. So, what's my point? I'm still thinking, what's my point? Bum, bum. Oh, okay. Come on, how do I count it? No, not disable. Shot. Bulk movement of fluids versus the first law. When you blow air outwards, the air initially has kinetic energy because the air molecules move together as a bulk flow. As the air slows down, collision occurs with surrounding air molecules. Organized motion becomes random molecular motion. Kinetic energy is converted into internal energy. Okay. I thought it was potential. That was just my stupidity. Because when I say potential energy, my mind is not coming up with an exact answer to what potential energy is. Correction not handled in. Gotta go check that. Correction not accepted. Okay. I did submit section 8, right? This internal energy, kinetic energy is converted into internal energy. This slightly increases the temperature and entropy of the surroundings. Ow. Okay, yeah, it could. It could increase the entropy of the surroundings. I mean, if that's the case, then this fan should increase the temperature of the room. Relation to the first law. The first law states energy cannot be created or destroyed, so the kinetic energy does not disappear. It is simply transformed from macroscopic motion to microscopic thermal motion. Kinetic energy does not disappear. It is simply transformed from macroscopic motion to microscopic thermal motion. Am I missing something? Maybe. Kinetic energy is converted into internal energy. The slightly increased temperature of the entropy of the surroundings. In relation to the first law states energy cannot be created or destroyed, so kinetic energy does not disappear. Oh, come on. Conservation of energy, first law, entropy. They do not contradict each other. They are blowing air example is correct. You would put Then the moving air slows bulk, kinetic energy, random molecular motion, so the energy spreads into the surroundings. Thermal energy confusion. So we say kinetic energy to thermal energy. Initially, many molecules moving together in one direction, organized motion. Later, molecules move randomly in all directions, microscopic chaotic motion. The total energy still exists. It just becomes spread out and less useful for doing organized work. Your sun question is actually very good. Shut the fuck up. The sun keeps losing. The sun is converting nuclear mass energy to radiation energy through nuclear fusion. A tiny amount of mass becomes enormous energy, so sun slowly loses mass. That mass becomes light and heat. Is energy being destroyed? No, the energy leaves the sun as light infrared, yeah, okay, and spreads throughout the space. Then where does the entropy come in? That's the important distinction. First law, total energy is conserved. Second law, energy becomes more spread out and less useful. Why sun is actually increased and radiates, yeah, even though total energy remains conserved. Big picture, energy conservation says how much energy exists. Entropy says how useful or concentrated that energy is. 230. Push-ups. I don't get it. Correction not handed in? Should I go to the university and confirm if the lab protocol is there? Because this is weird. So the sun losing its mass to energy, that energy is still spread across. Uh-huh. Mm-hmm. Push-ups. Fuck, I forgot. The fuck is this? Just a minute. push-ups. Okay, I'm gonna switch the cameras cause yeah, I'm gonna start writing. Fuck. Just a minute. Okay. That's too tall, right? Fuck, it's too tall. Yep. Nope. Okay. Okay, that's good enough. Do we need the fan? Nope. Again, I get distracted. Oh, fuck. $15 minutes. If I rewrite that, that does not look good. First, laws of thermodynamics. First, I write the laws of thermodynamics. Zero the if two systems are in thermal equilibrium with the third system, they are also in thermal equilibrium with each other. If two systems are in thermal equilibrium with the third system, they are also in thermal equilibrium with each other. They in thermal equilibrium with each other. Each other? Each. Just a minute. First, energy cannot be created or destroyed, only transferred or converted from one form to another. Cannot be created, destroyed, only transferred or converted from transferred or converted from one form to another. To another. Why is Microsoft open? What? Why is Microsoft Word open? Terminal, I'll work on you later. What? Second. Entropy of an isolated system tends to increase over time. Of an isolated system tends to increase over time. Third law of thermodynamics. I hate these space, like why are these space? How can I use these parts? Fuck. I should not get involved. Should not waste too much time, but it just annoys me, like these parts, this part is just not used to. As temperature approaches absolute zero, entropy of a perfect crystal approaches zero. As temperature approaches absolute zero Kelvin, the entropy of a perfect crystal approaches zero. Crystal. Bulk movement of fluids versus the first law. When you blow air outwards, the air initially has kinetic energy because the air molecules move together as a bulk flow. As the air slows down, collision occurs with surrounding air molecules. Organized motion becomes random molecular motion. So kinetic energy is converted into internal energy. This slightly increases the temperature and entropy of the surroundings. Bulk movement of fluids versus the first law when you blow air outwards. I hate. Oh, it looks weird now. Okay, bulk movement of fluid versus the first law. How does this process relate to the first? I copied it, right? Yeah, I believe I copied it. Answer basically the K in the bulk of air is distributed across distributed across converting still followed compared to the initial bulk amount. Okay. The famous thought experiment, physicist James Clerk Maxwell imagined the demon. As the moving air slows down, it's organized it's transferred through a collision to surrounding stationary air molecules where it becomes distributed as random molecular motion internal thermal energy. Thus, the first law of thermodynamics is obeyed because energy is not destroyed but transferred from bulk kinetic energy into internal energy spread across the air molecules. I think that's a pretty good answer, but I really wanted to mention the whole, what's it called? The whole, oh, I did that. Oh. As the moving air slows down, it's organized kinetic energy is transferred through collisions through the surrounding stationary air molecules, where it becomes distributed as random molecular motion, internal thermal energy. Thus, the first law of my handwriting is so bad. Thus, the first law of thermodynamics is obeyed. Thermodynamics is obeyed because the energy is not destroyed. But transformed from bulk kinetic energy, but it's formed from bulk kinetic into internal energy spread across many air molecules, into internal energy spread across many air molecules. Wait, I need to draw. We got 2 boxes. Random motion surrounding air KE specific direction bulk air. Okay. Motion. Okay, that's maybe good enough. Oh man. This is first question. This is what I hate. This is what I hate. I take too much time. But what's the point if you're not looking deeper into it? Well, I'ma end the stream, gang. I'ma end the stream. Peace.